Welcome to Off Hours, a conversation between John Edwards and Chris Manning.
Oh, John, we've spoken a few times now about some books that we've recommended and things that we'd like to talk about, but most recently we both read The Perfectionists, and we thought this might be a good book to start out the Off Hours book club with. This was something that you had recommended to me. How did you come about this book originally?
Oh, I don't recall how I came about it. I believe I read an article that was an excerpt from the book shortly before the book was actually released. And your memory on all of this book is going to be much fresher than mine because it's been a couple months now since I last read it, and I've read a number of books in the interim, so I'll be a little foggy on some notes, but I'll do my best to keep up with you.
I wouldn't place any bets on my memory, John. It's not spectacular. I'm relying on the notes feature in my Kindle to be able to keep up with what was in the book.
There's a few things off the top, just some little tidbits to get out of the way. For whatever reason, I enjoy getting to the root of where words come from. A little bit of an etymological bent to me. So I quite enjoyed the little hallmarking bit that you revealed to us a few episodes back. But three terms, or words rather, that came up through the book that Simon Winchester gave some background on the history of that I thought were kind of neat, were the terms Luddite, bouquet, and the company Leica. And so the term Luddite comes as the result of a gentleman named Ned Ludd, who was very resistant to automation in England during the Industrial Revolution, and he led some revolts of his own, and people who followed him came to be called Luddites. So that has now trickled down through history as a word that is often used to refer to people who resist new technologies. And would you like to handle the bouquet etymology side of things?
That is as close as I can tell to how it's supposed to be pronounced. I know a lot of people call it bokeh. So the term bouquet is coming from the Japanese word for blur. So when you look at the bokeh in an image, photograph, it's that blurring action that you see of things that are behind the subject primarily. It also happens with things that are in the foreground, but you'll primarily see it with objects that are behind your subject. And depending on how fast the lens is, you'll see that drop off very fast. And also depending on how far away the objects are from the subject, you'll see considerable bokeh. And you'll hear photographers talking about trying to find lenses with the best bokeh. So that's where that comes from.
That's the same effect that the dual camera iPhones attempt to replicate using the depth perception that enables. And then finally, very simply, the company name Leica was just the result of a concatenation of the founder's surname, which is Lights plus camera. So the first three letters of Lights and the first two letters of camera give you Leica. And that is a company that's obviously built a name for itself in the world of cameras as being a very perfectionist-oriented camera company. They make some of the best lenses in the world if you talk to people in photography circles.
Before we talk about the sort of the specifics of it, we should probably talk a little bit about what the book is discussing and maybe our overall thoughts of it. So the book is sort of a chase through history of the people who intentionally have worked on and advanced precision manufacturing and how that's had an impact on the world and also what they did to do that. So as you go through the book, you start with people in the 18th century working on what today we consider as relatively inaccurate items, and the progression from there to today's hyper precision world where we're working on things to ridiculous levels of precision. It's sort of a story covering the history of precision manufacturing. This book definitely struck all the right chords for me. This is exactly the kind of thing that I like to read, a little bit of history and a little bit of interest in the inventors and the items that they're working on. And sort of getting a sense of how we got to where we are today, because it's very easy to look at things that we make today, and so many people don't really know how things are made today. And it's nice to see where this began, because you and I have talked about the precision levels that we're dealing with in watchmaking, and at some point somebody had to decide this was how they were going to make something that precise. And where does that start? How do you get to that point? Because it doesn't just magically happen. There has to be sort of an intention to make an accurate thing. And so it's fascinating to see how that's progressed, and sort of where that intentionality began.
Yeah, in a way that Simon Winchester phrased it early on in the book that really resonated with me was that every great advance replaced traditional complexities with a new simplicity. And I thought that was a really elegant way of putting that.
Mm-hmm.
And another distinction that he makes early on in the book that I think is an important one is the difference between precision and accuracy. And there's a diagram in the book with 4 bullseyes on it. And actually, the first time I had ever seen this particular diagram was from a talk that horological writer Jack Forster gave at the Horological Society of New York earlier this year. And it's a very good representation of what distinguishes precision from accuracy. The first bullseye shows shots that are close and clustered around the center. And there's both precision and accuracy in those shots. And then the next bullseye that Winchester shows has the shots all clustered together, but they're not at the center of the bullseye. So in that case, it's a very precise shot, but the shots miss the bullseye, so they're not accurate. And then the next one has the shots widely dispersed. It's neither precise or accurate. And then in the final one, there's some clustering with a little bit of proximity around the center. And in that one, you would say that has a moderate amount of accuracy and a moderate amount of precision. So while they are often inherently used interchangeably, there is actually a very specific difference between what it is to be precise and what it is to be accurate.
Yeah, that's a good point. It's the two are not the same thing. The other definition that he writes about early on is the idea of how we define precision, and that's through tolerance. And this is something that those of us, again, who are used to making things are used to dealing in tolerances. And the tolerance is how inaccurate the thing can be before it's out of spec, before it's no longer within tolerance. And this was something that I remember a number of years ago. There were some rules for a competition that I was participating in, and the rule book explicitly stated that the box that was being used for judging was going to be a certain dimension, plus or minus, I think it was 100,000ths of an inch or something like that. And somebody was making somebody made the point, well, why can't we just make it perfectly precise? Why can't we make the box exactly the size that it is, and that's the box that we use? And of course, a number of us are like, well, that's not how the world works. You can't make the box exactly that size. And he's like, well, I don't believe that. He's like, I can make I can find a ruler and I can make the box so it's exactly that size. And so somebody who's a tool and die maker sort of jumped in and he said, look, you can make it, make a box as accurately as you think it is, and I will find a more precise measuring tool that will show you how inaccurate your box actually is. And that's also one of the threads that come through the book. Isn't just how to make things accurately, it's also how to measure them accurately, because without the ability to measure accurately, you don't know how accurate the thing is that you're making. So the idea of tolerance is it's often expressed as plus or minus a certain value. And so if you say it has to be 1 inch plus or minus 1,000th of an inch, then it can be anywhere from 0.999 of an inch to 1.001 of an inch and still be within tolerance. So that idea of tolerance is certainly something that's important, and that's what he refers to at the beginning of his chapters. So the first chapter begins at 1/10 of an inch, and from there he progresses on. And I think the end of the story, where he's talking about tolerances, I think it's something like 10 to the minus 28 or something like that. So it's a ridiculously small value that he ends up discussing at the second last chapter. In chapter 1, he starts out with a tolerance of 1/10 of an inch. And this is sort of the beginning of the idea of working accurately with with machinery. He's talking about the story of James Watt and the Watt steam engine. Now, James Watt was not the first person to create a functional steam engine that was put to use in industry. Newcomb was the first person to have a functional steam engine in industry, and it suffered from a lot of failures. James Watt made a number of improvements to the Newcomb engine, which allowed him to improve the efficiency of it. But one of the problems that he continued to have was there was too much inconsistency between the piston and the cylinder. And so he was losing too much steam outside of this, outside of the piston. And he was assisted by a John Wilkinson, who had figured out how to accurately machine the inside diameter of a cylinder, which happened to turn out to be perfect for James Watt. And so the two of them basically created the first intentionally accurate item where they were chasing tolerances. They were sort of intentionally working to these tolerances, and they worked. I can't remember what coin it was, but it was accurate enough that they could no longer fit. It was like a penny farthing or something like that in between the cylinder and the piston of this engine. So that's sort of where the story begins, is with this chase to make a more accurate steam engine, because then it would become more powerful and it would lose less energy.
Mm-hmm. And then that same technology was then translated over to making cannons. In a lot of ways, precision is what allowed the British Empire to conquer the sea.
Yeah, Wilkinson, his other claim to fame, as well as helping James Watt produce a more accurate cylinder and piston for his steam engine, was making a standardized gun barrel for the British Navy. And he was able to produce very consistent gun barrels that could handle exactly the same size shot. And so you could drop any gun from one ship to another and drop any ammunition from one ship to another, and they would all interchange and they would all work properly. So that was where Wilkinson made his real money, was in outfitting the Royal Navy. One of the things we'll see that's a consistent thread through the story is the British Navy is a regular sponsor of people trying to produce more and more accurate things, or in more and more innovative ways, because, as you say, they were responsible for English dominance in the world. And so they end up being sponsors of a lot of these characters through the story, which is fascinating.
And another aspect of the Navy's dominance that it seems unlikely or almost even trite, that precision would pay off there, but just in the tackle that was used for the sails, and having a standardized set of pulleys, essentially, that could be moved from ship to ship, and you knew that it was the same on every ship and could be depended on. And if I remember correctly, it was Henry Maudsley that was brought on board to head that effort. And prior to that, Maudsley, who we've referred to in a previous episode when we talked about threads, was originally employed by Joseph Bramah, who was a renowned locksmith of the era, and he also invented the fountain pen.
It was an interesting thread to see that. It's sort of just given a brief mention. He's saying that he launched onto the market a primitive form of fountain pen. I'm curious to find the patent for this to see what it was that he designed, because the earliest patent I had seen previous to that was an 1827 French patent that was given to a Romanian for the first fountain pen. and the Brahma one is from 1809. So I'd be kind of curious to see what it looks like and see what he did with it.
Oh, maybe you might be able to dig that up on a future trip across the pond.
Well, to see. I'm not sure where that's hiding. But Brahma was obviously an important character. He was an important inventor. It's funny because all of the stories, all the articles I've read about him talk about him being a lockmaker, but one of his inventions, and this has been far more useful than I think a lot of the things that he produced as a lock, is he invented the hydraulic press. And the hydraulic press is such a critical piece of machinery in manufacturing, in construction, because the whole idea of a hydraulic cylinder is critical for moving large amounts of material around. It's a massive force multiplier when it comes to getting work done. So it's interesting that there's, again, just a brief mention of the hydraulic press when this is something that's so incredibly important. And it's something I use all the time. I use my hydraulic press for deep drawing things, deep drawing caps and things like that. So it's he's responsible for a number of interesting inventions.
Yeah, it's hard to cover absolutely everything in a book like this, and I think that Simon Winchester did an admirable job of weaving a thread through it all. And I think the reason that he stuck with the lock side of things is because Brahma did have a locksmithing company, and he did make one of the best locks of the era. And that's also how you then end up with the connection to Henry Maudsley, because Maudsley worked for him.
And I understand that you don't want to stray too far from the book when you're writing something like that, but even other articles that I've read about him focus primarily on his lockmaking. I know that his locks are still being made in some variant today, but yeah, again, even other articles I've read about him really just sort of brush over the idea of the hydraulic press as something that he invented.
Yeah. And another of his inventions that many of our listeners might enjoy quite often in their off hours and have no idea about is the fact that he invented a system for keeping beer cold and under pressure underneath the bar of a pub.
Yeah, he prevented, or he created a way of delivering beer from the cold cellar up to the taps without needing to lug the heavy barrels up the stairs all the time. So yeah, if you're enjoying a cold beer, it's from a tap, it's likely that you're enjoying something that benefits from his invention. But I think the Maudsley is probably the more important of the two of them in terms of the story of precision, and his primary invention that I think has benefited the world the most. And he's done a number of things over the years in terms of what he created and how he improved manufacturing. But certainly the premier item is the carriage on a lathe. So on a modern screw cutting lathe, there is a carriage that moves back and forth along the ways, and it carries the tool that cuts the part. Previous to that, you were primarily using a tool that was handheld and was resting against a tool rest. And you can do some impressive work when you're just hand turning something off of a rest, but it's very difficult to repeat the work that you're doing. So if you want to turn something to 1 millimeter in diameter, turning it to 1 millimeter in diameter by hand is possible, and the more you do it, the faster you can get at it. But it is trivial to cut something to 1 millimeter in diameter using carriage on a lathe, because it's very easy to dial in the exact distance that the tool is from the work, and you can then make multiple passes until you get to the final dimension, and you can again repeatably, accurately turn to the same diameter over and over again. So this idea of putting a slide on a lathe and driving it from the screw is extremely important, and it's sort of fundamental to most of our modern manufacturing. Yeah, and we've discussed a lot about lathes, and we have focused quite a bit on that as a machine in the shop. And I think one of the reasons that we focus on that, and it's something that people don't necessarily appreciate when it comes to manufacturing, is that the lathe is really the foundational tool of the Industrial Revolution. In fact, in the book, he refers to it as the mother tool of the industrial age. The lathe is the only tool that can build itself.
Mm-hmm.
You can build every component of a lathe on the lathe. It doesn't matter whether you're talking about a mill or a shaper or something like that. It's impossible to create a machine of equivalent or greater accuracy on itself unless you're dealing with a lathe. So that lathe is that critical tool. And in fact, if you stuck me on a desert island and you said you could only have one tool, without a doubt, it would be a lathe. I use a lathe every day, and it is so fundamental to what I do. And again, it is that foundational tool, because from that lathe, I could then build myself the other tools that I wanted in the shop. If, with enough time and resources, you can use that one tool to do it. So it is worthwhile, looking at the lathe as this foundational tool. And Maudsley is really responsible for turning it from a useful tool to that foundational tool. And you'd mentioned earlier about the British Navy needing standardized block and tackle for their ships. And one of the things that impressed me was that they were in need of 130,000 block and tackle sets in 3 different sizes every single year, just to keep their new ships and existing ships on the water, which is just this is the late 18th century. It's remarkable to me to think that prior to Maudsley coming along, he ended up getting a contract to mechanize the production of these block and tackle. And prior to that, it was a few score of woodworkers who were making them all by hand. And I just can't imagine, 130,000 block and tackle sets being manufactured by hand every year.
Yeah.
It's just a remarkable number. So Maudsley, along with with everything else that he did, he really, again, is sort of the foundation of the idea of an assembly line, sort of producing consistent parts. And this was something that he did again for Brahma. One of the reasons why Brahma's locks were so in demand was because the parts were so well made and they were interchangeable. So those interchangeable parts, that manufacturing process was thanks to Maudsley. He then turned it into something that he could produce for the Navy, and in producing these block and tackle. And the interesting thing that one of the interesting notes in here was that the Royal Navy made its last pulley blocks in 1965. So this is something that they used for hundreds of years, and he was able to ramp up their production from to astronomical numbers, and where originally they were being made by a couple of score of trained woodworkers. I think they were saying that the entire factory that was producing these was being run by 8 people or something like that. It was some ridiculously small number of people were manufacturing these hundreds of thousands of block and tackles.
Yeah, and from one perspective, it's unfortunate that all those people were suddenly put out of work because of this innovation. But on the other hand, making block and tackles by the hand and trying to make everyone as close to the previous as possible sounds like fairly mind-numbing work. And I would imagine that there's some degree of liberation in not having a human be that hands-on in doing that work, and liberating them to pursue more fulfilling and creative, perhaps meaningful work. Yeah, it's certainly a two-edged sword.
Yeah, you certainly have the immediate aftermath of being fired from your job for, being replaced by a machine would be devastating. But again, as you say, these men have incredible skills. So, this leads to the Luddites as well. Now they were fighting against the mechanization of the textile industry, but it's the same idea. It's the same. It's happening at the exact same time, and this is the movement that eventually ends up leading into the arts and crafts movement, where the demand for handmade items becomes prevalent, and it's this pushback against the Industrial Revolution, and also a use for these skilled laborers, these people who had the ability to make these things by hand, but instead of mass producing things, they're now producing smaller quantities of handmade items that people are appreciating and they're paying more money for. So yeah, it's a difficult situation whenever you're in an industry that gets replaced by something new. But unfortunately it's just the way of the world, and it's going to happen eventually.
This particular period and time also marks the dawn of precision measuring instruments. So what can you tell me about the Lord Chancellor?
Yeah, the other notable invention from Maudsley is the first micrometer. And so, of course, as I alluded to earlier, when you start working on more and more accurate things, that accuracy is only useful if you can measure it. And he was starting to work to tolerances of 1/10,000th of an inch, so a tenth of a thousandth of an inch. And to give you some context for that, the average paper that you put into a laser printer is going to be about 3/1000ths of an inch thick. And he was working to tolerances that were at a tenth of a thousandth of an inch. So 30 times smaller than the sort of the average thickness of a piece of paper. And of course, working to those tolerances, the thing you have to be able to do is measure it. And when you start working on something that's a 10,000th of an inch, you can't easily see that by eye. You can't look at two items that are a 10,000th of an inch apart in size and say that one is larger than this one. And so the Lord Chancellor was the first micrometer, and it was the sort of the last word in the shop on whether an item had actually been made to specifications or not. So they were doing, again, this is early quality control, early quality assurance, and they were using this micrometer as a way of measuring. And again, part of the story not only is talking about the people who are making things more accurately, but also the people who are making the measuring devices. So yeah, the micrometer, the Lord Chancellor, this was the first instance of a sort of precision measuring device, well below what the human eye can easily distinguish.
Mm-hmm.
One of the fun stories that was in here that ties in a little bit to my shop is the story of Rolls-Royce and their origins. And in the book, he's comparing them to Henry Ford, who I guess Rolls-Royce and Ford are founded within a year of each other, but they took a very different approach to how they manufactured things. And in the case of Rolls-Royce, they were producing things that were extremely accurate, but they were producing each item as a bespoke item. So when you built the engine for the car, that engine was built for itself. It was unique. You could not take the parts from that engine and put it into another Rolls-Royce engine. They weren't interchangeable like that. And I know that in the 40s, the lathe of choice that Rolls-Royce had on their factory floor was the Cromwell lathe, and I happen to have one of those right now. That's what I'm using to make my current watch on. And it was an extremely precise lathe. And again, this was competing against some of the precision tool room lathes that were being made in America. And it wasn't made for very many years because the company that was producing them, they were producing them to a standard that was extremely high, and the cost was astronomical, and only companies like Rolls-Royce could really afford it. In fact, I've seen some of the original adverts for the lathe, and you could buy a house in London for less money than you could buy one of these lathes. So you can imagine they weren't flying out the door. And I think they only manufactured them from sort of 1948 to 1952. But yeah, that was it was nice to see that the story of Rolls-Royce being told in the book.
Mm-hmm. Yeah, there are a lot of things that Rolls-Royce has its hands in that you can buy a house for much less money than to acquire. One of these more modern things is actually jet engines, and an interesting tidbit from the book, and then later I investigated a little further and watched some videos about this too, that kind of ties into what we were talking about back in episode 3 of this show, and that is the art of lost wax casting. So in making their turbines, they actually use a number of proprietary, but the technique they used is still that ancient tradition of lost wax casting for making their turbines.
Yeah, it's interesting because even with all of the modern techniques that we have for machining things, 5 and more axis machining, 3D printing directly in metals and things like that. At the end of the day, the technology of lost wax casting, it's still such a powerful technique, and again, you're able to produce items that just are there's no other way to produce them through lost wax casting.
Yeah, and as amazing as 3D printing technology is becoming, and they are using that in some aspects of their work, it can't touch the level of precision that they need for making these blades, because what they're actually doing with the lost wax casting technique is lacing every single blade in the turbine with microscopic holes that air is channeled through to keep the metal cool and to prevent it from melting. Basically, you get this tiny layer of air that coats the blades as they're spinning in the turbine. And if it weren't for that microscopic amount of air flowing over those blades, they would completely melt down. And it's just critical that you have a proper airflow going through all that. And that's not something you could achieve with 3D printing at this point in time.
Yeah, the story about the jet engines and how they came to develop that technology was really fun to read, and it's fascinating to think that those turbines are operating in an environment which is hotter than the metal itself is supposed to stay solid at. They're thousands of degrees, and it's, I think it's like 500 or 600 degrees hotter than the liquid temperature of the liquidus point of the metals that they're using. So it's amazing that they're able to get these metals operating in such an extreme environment, and that, as you say, that ability to cast those channels into the part to allow the airflow to then protect the blade was pretty interesting.
Another tidbit that was not in the book that I just learned about recently, I think Rolls-Royce actually just announced it in the last few weeks, but their R&D division is actually developing collaborative swarm robots that will go in and examine the jet engines from the inside without having to dismantle them, just to make sure that everything is operating as it should. So these tiny little robots that are not much bigger than about a centimeter, if I remember right, will crawl all throughout the systems of the turbine and feed high resolution imagery back to the technicians, and they can pick up on any sort of errors or things that are going on there, which is, as the book makes quite clear, very critical, because a very small error that was made in a particular Rolls-Royce engine was responsible or found to be responsible for a particular aircraft crash a number of years ago.
Yeah, that was an Airbus A380 that came down. In fact, that incident, fortunately, it wasn't really I guess it was a crash landing. Everybody survived, fortunately, but it did ground the A380 fleets worldwide for a number of months while they tried to determine what exactly had caused the failure, because it was still a relatively early on in the service life of those A380s, so it wasn't something that they should have been able to see that early on. There's so many great stories in this book, and it really is worthwhile reading this just to go through and read about how he's making connections between the different levels of precision and the different industries that are using them, using new tools and new techniques and whatnot. But I think the one that relates most to us and above and beyond the ones we've already discussed was Chapter 8, where he's talking about time and accurately positioning yourself on the planet. Because at this point, he starts talking about the GPS system, which, of course, is the replacement for the longitude problem of John Harrison. And whereas Harrison was able to solve the problem through accurate clocks that were being carried on the ships, eventually GPS comes along, and again, using accurate clocks, although many, many orders of magnitude more accurate than Harrison's, they're able to then beam information to all parts of the world to give accurate time and placement on the planet. So the stories about how GPS was created and the levels of precision that it's able to work towards is just amazing.
Yeah, that part of the book, so much of the book being based in England, definitely brought some memories back for me of being at Hurstmont Zoo in the observatory there, because one of their telescopes with a laser rangefinder on it is responsible for making sure that these positioning systems floating around in the sky above us are keeping accurate time. Because if they're not synchronized correctly, then your coordinates that your receiving device would be calculating for you can be off significantly, and in certain circumstances, it can make the difference between life and death for you, particularly when you're out on the ocean.
Yeah, and it's fun to see how they're dealing with some of the problems of when you're starting to deal with these levels of accuracy and the distances that are involved. They start dealing with problems related to relativity, because time changes as you move closer or farther away from a massive gravitational field. And so these satellites are out far enough from the Earth that they have to compensate for relativity in the timekeeping that they're doing. So it was neat to see the way that they're dealing with that, and just that they're at that level of accuracy when it comes to dealing with this timekeeping.
Another facet of time that he touches on in the book is the House of Exquisite Craftsmanship on the other side of the planet, on another island much, much farther away from England, and that is in Japan. And he delves into the history and backstory of Seiko, which in Japanese means exquisite workmanship. And I found that an interesting story to weave through. There were a couple tidbits in there that I wasn't aware of about Seiko's history, most significantly being the Kanto earthquake in around 1923 that wiped out much of what the company was up to and had built to that point in time. The founder replaced 1,500 or so Seiko timepieces that were in for service at the time that just got devastated during that earthquake.
Yeah, the story about Seiko was great, and if you're a watch fan, then it's worth reading, just for, again, the topics on GPS and the atomic timekeeping that they're doing, as well as the story of Seiko. It was interesting to see what they were doing, and how early on he was able to create a sort of a mass produced accurate timepiece, and they really did have embraced a lot of the advanced manufacturing that's allowed them to continue creating incredible timepieces, and at quite a volume as well, because they are producing everything in-house for themselves, and they're producing it at quite a scale.
Mm-hmm. Yeah, Seiko continues to impress me today. Just the breadth of what they're able to achieve in their products. I mean, you can pick a Seiko up for $10, or you can pick a Seiko up for $100,000, and the qualities of each of those timepieces at either end of the scale is really remarkable. Just the precision of timekeeping that you can get from a lesser expensive quartz timepiece all the way up to the exquisite craftsmanship that you find in the Grand Seiko line, that in many ways is on par with what you would get from the finest independent Swiss watchmakers in terms of the level of fit and finish and quality. And for a long time, Grand Seiko was sort of Japan's best kept secret in horology. They weren't available anywhere else in the world. You had to go to Japan to acquire a Grand Seiko piece. But in more recent years, they branched out a bit, and you can now acquire them elsewhere on the planet than just in Japan.
Although a lot of the models are still only available in Japan.
Mm-hmm. Yeah, so-called JDM models, Japanese domestic market.
We've only touched briefly on a lot of the things that are discussed in this book, and it really is worthwhile going through. It's a great book to read, and despite what it might sound like, it is really not dry. The stories are fascinating and engaging. His writing style is excellent. He doesn't focus too much on the minutia of any one thing, and it is. I think it's interesting for anyone who's curious about the world and curious about what's going on in the world. So I highly recommend reading this book. It's probably it's been my favorite read of the year, I think. Yeah, I'm really happy that you recommended it, and it's a relatively recent book. I think it was published this year, so it's probably not something that you've come across yet, but I do recommend picking up a copy if you haven't read it. And I think you, I read the Kindle version, and I think you said that the audiobook version of it was excellent as well, right?
Yeah, the audiobook version was great. I did both the audiobook and the physical copy in tandem, just because I find it productive to be able to listen to a book while I'm working away at the bench.
Yeah, so it's an excellent book, worthwhile reading. We've got a link to the book in the show notes, so if you're interested in picking it up, I highly recommend that.
Anyway, thank you for listening, everybody. We will see you again in 2 weeks. The show notes for this episode will be up at offhours.show/EP23.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. John can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.